welcome for the last talk of the day, probably for most of you, cross-site scripting mitigation, state of the art. I would like to apologize for two things. First, we're French, so if the accent does not go well with you, sorry, feel free to ask us, we'll repeat. And the next thing is that, so we have tickets for Top Gun tonight, but that's not the schedule of the session. Sorry about that. So I'm JB, I'm staff engineer at Datadog. I came here with the screen acquisition. I was CTO and co-founder there, so I've been working in application security for a long time.
And I'm Vlad, I'm also a staff engineer at Datadog, and I joined Screen a long time ago too, and joined Datadog through the acquisition. Feel free to follow us on Twitter, we'll share the slide there later tonight or tomorrow. Speaking of the slide, here is the topic of tonight. We'll start with some XSS refreshers just to make sure that everyone is up to date on the attack. Then JB will describe the attacker point of view because he's a seasoned hacker and he will do a live demo of XSS exploitation. Then I will be talking about browser and server-side mitigation, and there will be another live demo, meaning that we have twice the chance of having things going wrong during the talk. And at the end of the day, JB will summarize it in a part named XSS threat models. All the links in the presentation are available at that QR code, but don't worry, this QR code will be also on our last slide.
So what is XSS? That stands for cross-site scripting, right? I'm sure you all know what this is. Basically, when you have user input somewhere and you can enter JavaScript or HTML in there, and it results in something like that. Have you all seen that? I'm sure you did. Who already exploited a cross-site scripting here? All right, okay. So, not beginners.
That's
perfect.
A hacker audience.
So, let's recap. What are the main cross-site scripting variants, right? So, first you have the vector. It can be either stored or reflected. Those are the most common vectors. Stored is in a database, in the local storage, maybe in the cookie sometimes, and reflected, it requires the user to do something so that the payload gets triggered, right? And then you have the injection. The injection is where the actual vulnerability lies. So it might be in your React application, it might be on your server-side code rendering. And last but not least, you've got the universal XSS. Here it's usually sitting in the browser. It might be in parts of the operating system, but something that is independent from the website. So those are the main categories. So back in the old days of the web, like 1995, the web was mostly like PHP, or a vast majority of the web was PHP, and you had like very little templating engines, and the ways you could exploit cross-site scripting was pretty straightforward. In 1999, the term cross-site scripting was coined by Microsoft, and the film didn't get a lot of hype at the beginning. It was a bit like neglected by security researchers as something not too important. And to be fair, the web was not as full as sensitive functions or information as it is today. But still, it took a long time. And you can still feel it from some old school security researchers that, yeah, cross-site scripting can be neglected. Now, despite being like 20 years old or so, in 2022, you still find cross-site scripting in React applications. It's still part of the OWASP top 10. It's part of the top 10 most discovered vulnerabilities and bug bounties, according to HackerOne. And I think if you work in a company of any decent size, that's something you know about. Yes. The web security model is something that is as old as the cross-site scripting because it was introduced by Netscape in 1995 along with the first versions of JavaScript. So basically that's helping describe how browsers should behave when it comes to handling several origins. So you have iframes, you have network communications, you have several resources that get gathered by a web browser, and the way the browser should behave from a security standpoint. Where should it send the cookie? What should it allow to read? Where should it allow the request? All of those kind of things are regented by the same origin policy, SOP in short. Obviously, all browsers have this frequency, etc. This thing from 1995 is still key to the way the security model of the web works today. And that great resource, the Tangled Web, is amazing if you want to refresh, and starts with the basic of the web and all the fundamentals of the web security. So cross-site scripting is a vulnerability, right? That allows an attacker to run JavaScript within a user web page or something. That's good, but so what do we do with it? A lot of outcomes are possible with cross-site scripting. And those are only a few. I'm sure I'm missing a lot, and depending on the context, you can find a lot of other things. So for instance, you could steal the session in some cases, steal the cookie, steal the authentication headers. You can achieve persistency with like modern workers in the browsers. You could do network pivot, which is a very fun thing to do. If you put that with a botnet, meaning that you compromise a lot of users, then you can achieve distributed denial of service. And one of the most important things that you can do is the action hijacking. So basically, if you have a cross-site scripting within a website, well, your code as an attacker is running with the same context as all the other code of that website, and you can do any action. So if it's on Facebook, you could add people, you could add friends, you could post messages. Probably you could wait that an admin is seeing that page and running action as an admin. So a lot of things can be achieved, and we can think of cross-site scripting as remote code execution for the web. It's like the somehow almost the ultimate vulnerability if you have a website, the ultimate vulnerability that can target your users. So let's see the attacker's point of view. That's a router that was used a few years ago in mostly Eastern Europe, and some malware managed using JavaScript to reconfigure this router. And what did it do? It injected custom DNS name servers. So every user of that router that triggered that malicious JavaScript payload got to use custom DNS configuration. And those custom DNS were redirecting some specific banking domains, and the attackers behind it stole the credential of a lot of those users. So that's one example of something that you can do with a cross-site scripting. You can pivot, change the network, access other things that would be on localhost. Here, obviously, attackers were using known credentials that the ISP were using for that routers and default IP addresses that were working in most cases. That's a list of exploits that have made cross-site scripting famous, so you still have a lot today. You can see a lot of them being added every day on some major websites. But if you look at bounty programs, for instance, cross-site scripting is still something that companies put very high in that list, despite that being a 20 years old vulnerability. And the most famous one is probably from 2005. I'm not sure we had any with a similar or as spectacular outcome. That was the Sami worm who added a lot, altered like 1 million MySpace profiles. So that's basic web security, right? So didn't change much in the way you exploit cross-site scripting. But you can think of other targets, right? Browser extensions, and one big thing is Electron apps that are also using web context. And here, cross-site scripting might be an actual remote code execution where a cross-site scripting can really lead the attacker into running actual code on the victim's machine. All right, so no need for, in some configuration, no need for fancy browser exploit or sandbox escape. Sometimes you have direct code execution. Obviously, Electron become much more safer in the past years to prevent those kind of things, but that's still something that you find. And obviously, you have some common bypasses. One of the most recent and interesting ones are the script gadgets. So they are assuming that you found a cross-site scripting exploit somewhere, but that some protections are preventing the hackers to exploit it. Script gadgets will leverage code from the frameworks to actually inject something that will get executed by the framework, which obviously is authorized, and will actually reach JavaScript execution. And content security policy that Vlad will describe a bit later is also something that can be bypassed. It's complex, it's hard to get perfectly right, and pretty often you can find bypasses within content security policy. So you have tools that will test them for weaknesses, and the content security policy evolved lately into something much more flexible, using strict dynamic, etc. It was very, very hard to implement a few years ago, and it's becoming more and more realistic to implement. So, demo time. So let's assume that I'm a evil hacker, right? So that black window is my hacker window, right? So this is BIF. BIF is an exploitation framework. So as an attacker, I might be using BIF in order to collect some cross-site scripting payloads that I've put on many websites, right? So what I will run as a JavaScript payload is not a script alert to demonstrate that it works. It's a URL pointing to BIF, my BIF instance, for instance. And that thing will allow me to do a lot of things on that cross-site scripting. So let's assume that I'm the administrator of a blog. That blog is running Ghost. And I'm visiting the website just to check if everything is fine. And here we have a page that is vulnerable to cross-site scripting and that has been injected by the attacker previously. All right, so as an admin, obviously, I don't know. The attacker would not label the page as XSS vulnerable, hopefully. And so when the attacker looks at their console, they can see that we have that browser who showed up, all right? So what can we do with that? You have a lot of information about the browser. That's pretty interesting. And you have commands. So commands are actual JavaScript payloads that BIF can instruct the victim's browser to execute. And so you can think of anything. You have like a Metasploit integration to exploit like 0 days on some browsers or whatever. And here, in that case, I wrote a very simple payload that allows to add a user in the website. So I will just put like some email. So that's my actual Datadog email. And I will execute the payload, okay? After just a while, we can see that the payload was fulfilled. And if, as a staff, I come back in the console, I can see that, yes, the user was added. So all I did was actually run JavaScript in this cross-site scripting session with the permission of the user, who is a blog administrator. And so that allowed me to do that, all right? That's a typical cross-site scripting exploitation use case where you are leveraging the actions that are available to regular users of the website, but silently. Vlad, my demo didn't break, so...
Okay, no pressure on me. Thanks, JB. So now, normally, the next question is how can we protect against XSS? And the question is multiple ways exist to protect against XSS. So let's start with what happens browser side. Small disclaimer, sometimes mechanism in the browser necessitates mechanism server side, so maybe the separation we made is a bit arbitrary. Let's just go with it. So first solution, no JavaScript, no problem, right? So disable JavaScript might be, please don't do that, might be a solution to disable XSS. One of the pros, basically no XSS. Cons, well, you need to ask your own user to remove JavaScript from their own browser, which is challenging on modern browsers, and also that will remove access to the whole modern web. So sorry for French, I did not manage to get this error message in English, but that's basically Twitter yelling at me for not having JavaScript enabled. Funnily enough, in 1999, when JavaScript and the threat model of the web was not that mature, there was a CVE published impacting Netscape Navigator and Internet Explorer, why they would say that JavaScript could be used to track user over the internet. The time have changed. So anyway, please don't disable JavaScript and don't encourage anyone to disable JavaScript. This was totally a jokey slide. Content security policy. So content security policy, JB already a bit touched based on that. Basically, that's a header that you add to the website where you serve it. And you define where the assets used by the HTML documents can be loaded from. For instance, you can say that the scripts can only be loaded from a certain set of domains, or that the images can only be loaded from the current domain. And you can even put hash, integrity hash, to make sure that script images, style sheets are not tampered with. That's actually pretty powerful. There is something extremely cool with CSP, and not CSP policy, because that would mean content security policy, and that would be slightly redundant. So the thing with CSP policy, is that you can monitor them. So when there are violations, the browser will send actually a post request to a server that you defined in your CSP, and you can monitor that. You can also configure your CSP to be non-blocking or blocking. I will come back to that in a minute. So CSP is easy to monitor, but that requires a lot of traffic going your way. So there are a few SAST that can be used to monitor CSP in the wild and let you know in real time when your CSP is, when your policy is actually being breached, which could mean two things: you're under attack and someone found an XSS, or your website is broken because your CSP is not up to date. Shameless plugging, Datadog can help you monitor your CSP. That's the only piece of advertising in this talk. Sorry about that. CSP might be hard to maintain because you have to update it each time you update your assets in your website. Let's say you want to have a new dependency from a CDN. Well, you need to make sure you update your CSP. Otherwise, this asset, image, script, anything will be blocked and your website will be broken. Thankfully, thanks to monitoring, you will know that faster than your customer will complain. But it is not supported by very older browser, as most of what we will discuss today anyway. So feel free to check that out. That's a really cool piece of technology. But can we go even further than CSP? Yes, we can. Introducing trusted types. Trusted types is probably my favorite XSS defense mechanism, mostly because I'm a JavaScript nerd. But basically, you have a CSP and you define what's called a trusted type policy in it. So you say, hey, I will create a JavaScript piece of code that I will name sanitizing policy. And each time you call in JavaScript what are called the sinks, well, it must go through a sanitization method before that. So let me start again. Trusted type considers that there are like 3 things for XSS. Create HTML when you call inner or outer HTML on a DOM element. Create script when you call eval, for instance, or create script URL when you load dynamically a script from another piece of script. When you enable trusted types, you create what's called a policy, which is just a set of JavaScript function. And when you call inner HTML, for instance, if you call inner HTML with a string that is not the outcome of a sanitizing function, this will refuse to execute. We will demo that in a couple slides, but the idea is that you cannot use these things without going through the policy. Before I go to the live demo and have a chance to do something wrong live, let's talk quickly about DOM Purify. DOM Purify is actually a library. It's pretty mature, it's an open source project, and basically what it does, it sanitizes inputs so they can be used safely rendered in the browser, in the DOM. So it's really lightweight and it plays really well with trusted type. But as any of these kinds of libraries, it can have false negatives or false positives. So one must be really aware of the behavior of DOM Purify when they use it. Also, since it's an open source library, everything is public, and you can find older bypasses in the previous version of it just by looking at the changelog. The really cool thing is that DOM Purify is actually under the process of becoming a web standard under the name of HTML Sanitizer API, which is currently supported by 0 browser, last time we checked. But that's an exciting part because the web is currently building more and more tools to fight XSS from your code base dynamically. Okay, that's the part of the talk where I'm terrified, so let's go for demo time. In this demo, we will just play with the same website. Let me zoom in a bit because, wrong keyboard. Yeah, so that's a website that says hello. I was too lazy to write world. So let's make it a hello world website now. Username equal world. And now it says hello world. That's basically, thanks, JB. That's basically a website that you can use to greet anyone, and you give them the URL and say, click on that, and they are greeted by that. The hackers here recognized reflected DOM-based XSS, and that you can forward to people through social engineering. So let's exploit that, shall we? As you can see, it has been programmed by someone who doesn't know much about the web. So if I do emg.src equals x, which is an invalid URL, or I even put a z here, and we can put an on-error callback, on-error equals alert. And let's try that. And here we are running arbitrary code, and we can send that to people, steal their credential and their bank account money, and pretty much impersonate them because we steal their identity, which is terrible. So let's fight against it. To fight against it, we will first try to enable a CSP. So if we check the code of my web page, you can see that I'm a very good web developer. I'm still using Align Center because I didn't want to put CSS in that. We can inject a CSP directly into the HTML page. We don't really need headers. The web is well done. So let's say we want images to be only loaded from the same domain. In theory, that should prevent loading this arbitrary image, right? Let's try that. Okay, so, good thing, it's already there. We still have an XSS. Why? Because actually the XSS is not unloading the image, it's unloading the arbitrary scripts that happens when we can't load the image. So if I check the console, inspect, that's not my laptop, and JB has a French keyboard, that's why I might be lost. If we check the console, it tells us refuse to load image because it violates the content security policy. So it doesn't want to load the image, but the script is not part of the image. So it's a valid thing. So what we need to do is actually prevent loading scripts from arbitrary places. So I've updated the CSP, and now I've got content, script SRC, and then I put a nonce. Yes, you can either use hashes, domains, or nonces to define what asset can be loaded. So in that case, I just generated a random UID, and in the script that runs the code, I've got this as a nonce. So basically, this CSP means the only JavaScript that's allowed to run on this page is that one, and none others. Okay, so let's check that in real time. I still have my exploit in the URL, refreshing, and we don't have the XSS. Woo! Yeah, we saved the web. Okay, it would be too easy if we didn't use trusted types, and because I'm at a security conference, I want to show some real JavaScript code because I'm a JavaScript nerd. I think I mentioned that already.
We know.
So come on, I made all my career with Node.js, don't be mean. So, you know what? Let's add a trusted type. Let's say that we want to be better than that and to have dynamic. So I still have a CSP no policy. And I say trusted type my policy. And I also say require trusted type for script to make sure it knows it's not allowed to run scripts without trusted type. Okay, so I told you that the policy needs to be defined. And thankfully, there's actually an API available directly in the browser. So we do trusted type.createPolicy. We give it a name. So I name it my policy, like my first dog. And in this policy creation, you create something for the things. So I told you there are three things, one for HTML, one for JS, one for JS for URL. This one is for create HTML. So that's a function that takes a string as argument and returns a string. Okay, that's an easy function. It does not sanitize much, but let's see if it works. Let's try that. So it's step 3. Oh my God, spoiler alert. I refresh, and here I write username equal world, and nothing happens. Why? Because I forgot to sanitize my content before passing it to inner HTML. Let me show you the error in the console. Uncode type error failed to set the inner HTML property on element. This document requires trusted HTML assignment. Why? Because here I'm assigning to inner HTML without going through the sanitizing function that I have defined in my policy. So let's do that properly. We have exactly the same code, but here we call window.mypolicy.createHTML, and now this outcome of this function is actually allowed to be used for inner HTML assignment. Okay, so let's go to the next part. Let's refresh, and we still have an XSS. Why? Of course, because my sanitization method was not sanitizing anything, right? If we check the sanitization method here, it actually returns the argument, so it's not sanitizing anything. We are missing the last bit of the part. So let's go to step 5. Oh my God, it's been written so well. And here we are calling DOM_purify, which actually sanitizes the input. So let's go to the step 5, refresh the page with world as an argument. Zold, yeah, that was my first nickname on the internet. And voila, it works because this thing is not actually a malicious payload. And if I go back, because I'm too afraid of typing a typo, I refresh, here you have my exploit, and it doesn't do anything because it has been sanitized by DOM_purify, configured in very strict mode. So far so good. We did 2 demo over 2. JB, can I get a high five, please?
So I'm going to give it to you, but you know we're in security conference, Vlad? Yeah, and you just give the entire audience the name of your first dog.
Oh, yes, true. Damn it. So let's talk a bit about the cookie thing, because JB and I have an obsession with cookies. I mean the treat, not the...
Both. Okay,
so it's actually really important to consider cookie when you are considering the web threat model altogether. You must use HTTP only, so your cookies are not available through JavaScript. Disclaimers that won't prevent people from impersonating your users through XSS, but that will prevent people from taking these cookies and taking them somewhere else, like escaping, stealing those cookies. So they can still use them in the scope of the vulnerable website, but they cannot take the cookies outside. For the other parts, they are not that much linked to XSS, but any slide about cookies should talk about all these attributes. So let's go really quickly over them. Secure, the cookies can only be exchanged over HTTPS, no unencrypted traffic. Domain, path, and SAST, we know exactly on which host those cookies are sent to. So this prevents cookie theft. This does not prevent escalation. Please do that. That's really like web security 101. And in doubt, just follow Mike West, who is a guru of the, and the Google team altogether are exceptional in terms of evangelism around XSS and cookies.
And also in terms of writing the next generation of web protections, Google, but also like Mozilla, those browser teams are really pushing forward, and that's very often thanks to them that Safari, for instance, is catching up, Apple is catching up on those security measures. So just a word on the future of browser defenses. We talked about what's available today, or mostly available today. Content security policy continues to evolve. The most common kind of evolutions on it is it's following the browser's evolution, you know, with worker scripts, with WASM, and all of the things are able to be expressed in a policy, so you can restrict them accordingly. So the HTML sanitizer API that Vlad described, you know, it's very hard to write parsers, and so it's very hard to write two parsers that will behave in the exact same way. So each browser is different. So when you are using DOM Purify, it's sometimes difficult to ensure that you have the same level of protection across all browsers. You can often exploit like mismatches between the DOM Purify parsing mechanism and a specific browser parsing mechanism. And the HTML sanitizer API will make it built into each browser, so the parsing engine of each browser will be used, which should supposedly make it much stronger. And if, like a common way to bypass DOM Purify is just to look at the fixes on GitHub, and you will see often fixes for incoherencies. And supposedly, if the parsing mechanism is the same as the web browser, that should not happen anymore. Another hard thing is Spectre and side channel attacks protections. So you know the principle. Spectre allows leaking any piece of data from a given process. So that's a very powerful attack. But if we consider that from the web point of view, that makes it very hard because as a developer, you need to understand the security model of the browser, and you need to know whether an iframe is loaded in the same process, whether a subdomain is loaded in the same process or not, and all of that makes it very, very hard for web developers to cope with the implementation of each browser, obviously. So the web browser vendors are currently improving the way they protect against that. Google is very active on that front. They shared some exploits that can run, and they have exploits for most browsers and on most platforms. It's not only Intel, it works on M1, etc. So that's a real thing, and the way you can defend against it is pretty complex. You have a fair part of new security headers that are restricting what browser can do from one another. And if you are using stuff such as a shared array buffer, then it's you will get error consoles if you didn't set the proper headers in the most recent Chrome versions. Private network access is also a security measure that will prevent the kind of attacks where we've seen attackers pivoting on your internal network to talk to your internet box, for instance. Document domain is being deprecated. And last but not least, the credential management is also being proposed currently. The good thing is that will make a browser-specific mechanism to handle login and logout, and that hopefully will remove the ability for malicious payloads to spy on the keystrokes. Vlad?
Thanks. And now we got you with the fancy modern way of protecting against XSS in the browser, because the browser is the future. Let's go to the boring old server-side stuff. Okay, so XSS server-side, they happen when you render HTML, right? When you have unsafe stuff rendered into the HTML, which is just a string document you share over the internet to the whole world. Well, the question of how this document is rendered, how this string is constructed, actually has an impact on your attack surface. So let's talk about things from when JB was younger. PHP. I was still in primary school. I
learned programming with C, but I learned web programming with PHP.
And back then, you still now, but probably less than now, you just do PHP echo with a variable. And that's just like a string replacement, you know? It doesn't care about what it is rendering, where, why. It's replace strings. And that's pretty much it. So here, the templating engine does not have any context about what it is actually doing. It's just building strings. That's why you have high risk, because the tooling can't help you. It doesn't know enough to help you. However, if you get to moderner stuff like ERB, EGS, well, it's context agnostic, but it still knows that it is rendering something that should be escaped. So, full disclosure, I'm not really a big fan of this syntax because escaping is just made by using an equal after the percent, and not escaping is using a dash. And I find that like really error prone. That's not explicit enough in my opinion. But anyway, what happens here is that it will escape the content of the username variable, HTML escape, to make sure that it is not rendering HTML tags. And on the last one, that's such a great animation, JB. And on the last one, here we are using directly another language that has nothing to do with HTML. So it has a lot of context on what it is rendering, and it can know what it is doing and reduce the risk surface. We will see in a couple of slides what is the future, because it's definitely doing something with JavaScript directly. Okay, I'm not sure why we had this animation here. Okay, so also I told you that CSP was hard to maintain because you have to update them continuously. Well, just tune your server-side stuff to help you there. For instance, here we can ask the templating engine to generate the nonces for the script, meaning that nobody will be able to inject a new script because you told the engine, I'm generating a script tag, so it will generate a nonces for this one. But if you generate rogue script ones, they won't be added to the CSP. However, that won't help you if the script tag itself contains part of code that can be injected. Like if you let people dynamically write JavaScript variables in the script you render, you're probably doomed for eternity, in my opinion. But that won't protect you against that. That's not a silver bullet. And templating engine, as I said, are getting smarter and smarter. So I will talk about React for a slide. React is actually fascinating because it's isomorphing JavaScript, meaning it works in the browser and server sides. And it has different ways of mitigating XSS, depending on when it's running in the browser or server side. In the browser, it will be using safe APIs. It will be using element.txt content instead of inner HTML. There's actually a method in React that's called dangerously set inner HTML, and probably there's a comment around it, do not use it, but it has dangerously in the name. So the only way you can shoot yourself in the gun while using React is by calling a method that has a name that dooms you for eternity. But on the server side, how does React do? Well, React actually is aware of what it's doing because components are defined in JSX. So on line 5 here, we've got a JSX component, and React is aware of what it should be rendered and what should not be. It's like the next generation of that. So here I'm rendering it server-side, and React has actually comprehensive XSS filtration mechanism. The only bypass we found is using JavaScript : in links and stuff. And actually, when you do that server side, there is a warning message saying, oh, that's working right now, but in the next version, this will be deprecated because that's actually unsafe. So the only bypass I found, they were already aware of that, and they are fixing it in the next version. That's a brilliant library, and that's amazing. And that's JavaScript, so it's amazing. Okay, let's go deeper in the traditional mechanisms, I would say, to be polite. SAST, Static Application Security Testing. That means that you have a program that will just read your code and find vulnerable points. There have been amazing talk earlier today on that exact topic, and that's a very strong technology. They have made a lot of progress on that front, and that works really well when you have properly typed programming language. So in Java, static analysis is extremely powerful. In JavaScript, well, JavaScript is a weird language, so it is so polymorphic that static analysis can be extremely complicated. but this is an important tool that you can use, and there are like a lot of vendors of free tools to do SAST nowadays. And that's probably my favorite slide, not only because it's 3 hours old, but that's, if you want to take a picture, take this one. Yeah, because it's incomplete, but it gives you an idea of what you are doing. Depending on the protection you are using, you are actually mitigating a given risk. And there is no silver bullet to fight XSS. This is like a teamwork between all the mechanisms that are available in the web. But I don't want to spoil the next part.
And yeah, just on the previous one, you could visualize it in 3D and imagine the browser supports, right? Yes, thank you, Glenn. You could visualize it in 3D, and including the browser supports would make it extremely complex. That's already not simple, but yes. And you can notice the star on the first line, which is all the new cross-origin things that have been added recently, and that make it very unstraightforward, to say the least. Mm-hmm. So on server-side mitigation, what is coming next? There still are a fair part of the web, and they will still be, right? You can use React server-side or browser-side. Ruby on Rails is not ready to go away. Java and GSP and everything. So we have some solutions. At development time, obviously, you could pick templating engine that will automate CSP generation. You already have similar things in Webpack, in Rails, in Django. For instance, in Rails, using secure headers with a well-defined templating engine that would automate most of the work for you. And then you have some security products. So something that I'm not really aware of, but that should come, and all the new browser APIs are making it much easier to implement. You could have DOM XSS protection in the runtime in the browser, so that will really help. Also, could work in detecting vulnerabilities. And the second part will be led by APM vendors. So since APM vendors have access to all the context of the application, something they can do is actually instrument themselves the templating engine and dynamically inject nonce and build the content security policy accordingly. And so those things will probably arise in the next few years. So we talked about everything that was like right. So now let's shift left and think about the design and the threat model. So shifting left means you want to be in full cooperation with developers and just ask them the right questions, right? So in a very nice way, not at all in a scary way. So don't do exactly that. Let's rather use those kind of topics that should help you get a fair understanding of how the application is working and what part as a security team you should focus on. So for instance, HTML generation. Okay, how is it done? Is it static? Is it dynamic? Are you using cross-site communications with other iframes or other domains maybe? What about the clients? Is the app or the service talking to the browser, to another service? Is it only generating JSON? Is it an API? Of course, the inputs, where are they coming from? Is that the network, the data stores, the user? And of course, there is the business level. So is the application doing authentication of the users? Are the users admin, support, or regular users? All of that has very depending privileges. And of course, is the app using sensitive business functions like deletion, permission management, adding administrators, as we've seen in the demo. And in each threat model that you can do with the developers, it's sometimes not easy to ask the right question. It might end like that, so don't do this either, please. So depending on the frameworks that you are using, the risk will be very different. So that's also something you need to pay attention to as a security team. So in the case of server-side rendering, Well, the vulnerabilities might be server-side and also client-side, because you will be using, I don't know, like jQuery or Vue.js or Rails fancy stuff that will make it potentially complex to audit. In the case of a single-page application, well, it might be much easier to audit because all the inputs are coming from the network, and so you can really rely on the application. If you are using trusted types on top of that, that will make the auditing much easier. So it's the simplest to audit. I would not say it's simple now. And of course, we have the hybrid version of it, where here you can have vulnerabilities everywhere, and that really makes it the much harder to audit, to reason about, as a developer or as a security engineer. Obviously, supply chain security is also a big part of the game. So all the remote dependencies that are included by a web application can be tampered with. You could have cache poisoning attacks. The hosting can get compromised, and non-HTTP fetching, because like attackers could man in the middle the dependencies. And so you have some partial solutions using, for instance, sub-resource integrity, SRI, that will allow you to add the hash of a dependency within the script tags that are requiring it. That can be automated using, for instance, Webpack. Another option would be to bundle locally. In that case, obviously, it's not magic, because if the hosting has been compromised before you fetch it yourself, then you will still be screwed. So now, let's take a step back and resume what we have seen during this presentation. So we have defense in depth. When a vul is introduced, obviously, you can use modern frameworks, threat models, static application security. During the runtime, to prevent vulnerability exploitation, then content security policy mechanisms, RASP and APM like mitigations. And last but not least, to prevent the attacker's outcome, you have a lot of other things like all the headers that we've seen, cookies attributes, browser hardening, and down to bug bounties and pen tests. That's it, folks. Thanks for your time today. If you have any questions, happy to.
Can we take?
Happy to take it. Or we don't see much with the map. Yeah.
No question.
No question.
Good. I want to see the drawing.
One question.
Oh, one question.
Hey, is there actually in effect any difference between a content security policy that's inline of an HTML page or one that serves via a header, or are they effectively the same?
So the question was, are there differences between an inline content security policy and one that has been set through headers from the server? I think from the browser's perspective, not.
Yeah, so you can, content security policy, you can use report only mechanism to not apply the policy, but just learn from it. So you get the violation reports when something goes wrong, and that you cannot use in the browser. So that's one first thing. True. And then it's useful for testing, but from an enforcement perspective, you could imagine that the page has an XSS somewhere where the policy is prevented from being injected. So the specifications say don't do that. Yeah. You can use it for testing.
So it's mostly for testing and demo purpose, yeah. Amazing, thanks so much. Enjoy the rest of the weekend, and thanks for coming to our talk.
Thanks.